All right. Just for the record, if if you're one of my students or something like that, I'm about to do the lesson that comes from this title, but I might as well call it 1B because now I'm doing the logic part of this lesson. So today's lesson is not about polygons. This lesson is about logic, specifically converse, inverse, contrapositive, biconditional, and also the laws of syllogism and detachment. Okay, so let's review this very briefly. If an original statement is of the form if P, then Q, and that's how we model that. Remember that the converse is the one that is backwards. So the converse would be of the form if Q, then P. Now, the inverse is the one where we follow the original order, but we negate both parts, the hypothesis and the conclusion. So the inverse is of the form if not P, then not Q. All right, notice it follows the original order. The contrapositive is the one where you negate and reverse. So it'll be of the form if not Q, then not P. Now, the biconditional, you can go ahead and write that in the original order, but you state the hypothesis and the conclusion, but in the middle you say if and only if. All right, this will be translated as if and only if. And that's how you would read this double arrow right here. So keep that in mind as a little review. So for number 20, since the original statement is if Megan plays Farmville, then she will not do her homework. The converse we would get by reversing the hypothesis and conclusion. So the converse should be if Megan does not do her homework, then she plays Farmville. So the converse would look like this. If Megan does not do her homework, then she played Farmville. All we did for the converse was reversed these two. Notice the if still stays in the front and the then still comes second. Alright, they don't move. We just take the Megan plays Farmville part, and that became she played Farmville. And we took the she will not do her homework part, and that came first. Megan does not do her homework. Notice how we had to change a few words to make it grammatically make sense. That's okay. That happens. Alright, now the inverse. Going back to the original statement, the inverse will just be negating this. So the original statement again, if Megan plays Farmville, then she will not do her homework. Now to negate both of these statements, first of all, if Megan plays Farmville, this would become if Megan does not play Farmville. Alright, the second part of the sentence says, then she will not do her homework. Notice the not is already there. If I wanted to negate this, I'm going to actually wind up taking the word not out of the statement. That's how you negate something that already says not. So the second part will come, then she will do her homework. So that is going to look like this. Now the contrapositive, remember, is the one where we reverse it and negate it. Okay, so that's going to be like this. Let's see, so this one is already negated. All we have to do is reverse it. Okay, so if I kind of look at the purple one and just write it backwards, so if this one says if Megan does not play Farmville, then she will do her homework, that's already negated. So if I reverse it, it'll be if Megan does her homework, then she did not play Farmville. Alright, I believe I mentioned that a biconditional is formed by taking the hypothesis and conclusion and putting if and only if in the middle. So this particular problem, the hypothesis is Megan plays Farmville. The conclusion is she will not do her homework. I should probably erase a little not. Let me try that again. The conclusion is she will not do her homework. If I take those two and I put if and only if in the middle, that's going to be the biconditional. So the biconditional would be Megan plays Farmville if and only if she does not do her homework. And that would look like this. Please note that a biconditional is really a matter of taking the original statement, let's put a little star next to it, and the converse, and putting them together. So in other words, biconditional, notice it has the word bi in it, the prefix bi meaning two. This biconditional statement takes the place of both the original statement and its converse. Okay? So you could basically take a biconditional and break it up into two separate sentences, and the first one would be if Megan plays Farmville, then she will not do her homework. The second one would be if Megan does not do her homework, then she played Farmville. Put them together and you get Megan plays Farmville if and only if she does her homework. Wait a minute. If and only if she does not do her homework. Man, I messed that up a little bit. It says she will not do her homework, so that's the conclusion. So this should say if and only if she does not do her homework. Glad I caught that. If and only if she does not do her homework. Okay, notice I am not negating anything. The original statement has the word not in it, so I'm just including that. Alright, anyway, let's move on from here. Draw a conclusion using either the law of syllogism, which is the chain rule, alright, the chain rule, alright, that's your syllogism, or the law of detachment. Chain rule. Okay, state your conclusion which you used. Alright, if it's going to be syllogism, it'll be the one that's of the form if A leads to B and B leads to C, then A leads to C. Alright, the first leads to the last. That's the chain rule, that's syllogism. Alright, detachment is the other one, and that's just sort of common sense. Okay, if A leads to B, and then I tell you that A is true, then you can assume that B is true. So let's see, number 23. If two lines are parallel, then they do not intersect. Line A is parallel to line B. So what can I conclude? Line A and B do not intersect. Okay, lines A and B, whoops. Okay, lines A and B do not intersect. Okay, I'm using detachment. Detachment is the one where if I tell you if one thing happens, then the other thing happens. And then I tell you the first thing happened. and you conclude the second thing happens. Okay, so in other words, detachment follows the following pattern. If A happens, then B happens. Okay, and then we are given A happens. And we are being asked what we can conclude. The conclusion is going to be B happens. Alright, and that B happens statement is your conclusion of a detachment. So, if two lines are parallel, that's your if A happens part, then they do not intersect. That's the B happens part. Guess what? Line A and B are parallel. That's the A happens part. Then the conclusion is lines A and B do not intersect. That's the B happens conclusion. Anyway, number 24, let's see how that one's different. If a quadrilateral is a square, then it has 4 right angles. If a quadrilateral has 4 right angles, then it is a rectangle. Do you hear how that part in the middle sort of repeats? Let's look at it again. Alright, if a quadrilateral is a square, then it has 4 right angles. Now, do you see how that green part repeats? If a quadrilateral has 4 right angles, okay, we just said that, then it is a rectangle. Okay, so the way syllogism works is that well, okay, this is going to be the law of syllogism, so I can go ahead and write that down because you can hear the chain. The syllogism goes like I said above. It follows the pattern: if A leads to B and B leads to C, then A leads to C. It's like a chain. So for this particular problem, this is, let's see, this is like our A, and this is our B, and this is B again, and this is our C. So A leads to C. So the conclusion should be, if a quadrilateral is a square, then it is a rectangle. So that would look just like this. If a quadrilateral is a square, then it is a rectangle. Okay, and we were definitely using the law of syllogism. Okay, should probably make that red so you can see that that's the answer. Okay, and that is it for this little logic review.